So, it has to do something with even odd functions, they will be helpful in this substitution while getting the integrals. So, suppose recall what is an even function, say on the negative side f of minus x will be equal to f of x, that is how even functions are, and odd functions f of minus x will be equal to minus of f x. So, suppose we have an even function, so that means the first one f of x equal to f of minus x, right. So, suppose we have the symmetric interval minus a to a, it is a very restricted case we are considering, even function and our limits are minus a to a. Then if you take t equal to minus x, we get minus a to 0, it will be really sum of two integrals, right. So, sum means it will be integral minus a to 0 f plus integral 0 to a f. So, first one we are considering for using evenness. So, it is minus a to 0 f of x dx, which is you can write say t equal to minus x. So, f of x is f of t d of minus t, right, because t equal to minus x, and when it is minus a, x equal to minus a, t becomes a, x is 0, t equal to 0. So, a to 0, it is a rule of substitution now with t equal to minus x. The differential dx becomes minus dt, right. So, d of minus t. Then it gives a to 0 f of t d of minus t, and that is 0 to a f of t dt. See, minus a to 0. So, it does not matter whether you change this, you can write also as 0 to a f of x dx, right. The variable does not matter here, it is definite integral, anything you could have taken. So, we can write 0 to a f of x dx, it is dx not x. Then the integral what we wanted from minus a to a will be minus a to 0 f of x plus 0 to a f of x, which is now equal to twice of 0 to a f of x dx. So, sometimes it becomes easier because at 0 we have to evaluate, that may be easier to for evaluation instead of going to evaluate at minus a, that is the way it helps. Okay. Now, we go for the next one, which is an odd function. So, it looks something like this, f of minus x will be minus of f of x. So, suppose g of x is a continuous odd function on the symmetric interval minus a to a. Now, again with the same substitution t equal to minus x, we find that minus a to 0 f of x dx. Now, f of minus t becomes minus f of t, and d of minus t we kept as it is, and the limits when x is minus a, t is a. So, it is a to 0, 0 is 0 of course. So, that gives rise to minus integral. So, this is really integral a to 0 f of t, 1 minus here cancels dt. Okay. So, that is same thing as minus of integral 0 to a f of t dt, which is again minus integral 0 to a f of x dx. So, when you take the sum, this kind of sum minus a to 0 plus 0 to a, they really cancel out and they give 0, right. So, what we get? So, this implies integral minus a to a f of x dx equal to 0. So, for an odd function you can see also geometrically how this happens. This is a signed area. So, this area and this area really cancel out, and similarly this area and this area also cancel out, fine. So, you get minus a to a totally 0, and here similarly these two are same. So, this becomes total becomes twice of this region, right, area of that region. So, that is what we say, if it is even it is twice, if it is odd it becomes 0, the integral becomes 0. Sometimes it helps to simplify some integrals. Okay, let us see how it is applied. We want to evaluate the integral minus 2 to 2 x fourth minus 4x square plus 6 dx. So, now is it even odd something? Well, we know x fourth to be even, it is a symmetric interval minus 2 to 2, x fourth is even, x square is even, 1 is also even. So, this is really an even function, right. So, now this, since this is an even function and it is a symmetric interval minus 2 to 2, we can straightforward write minus 2 to 2 f x dx integral equal to 2 times integral 0 to 2 f of x dx, which is x fourth minus 4 x square plus 6, which can be integrated now. So, x fourth gives x fifth by 5 and minus 4 x square gives minus 4 x cubed by 3, right. X to the power 2 gives x to the power 3 by 3 and 6 into 1. So, that gives 6 x. It has to be evaluated at 0 and 2. So, that when you simplify, you would get the answer as 232 divided by 15. So, instead of this whole expression again evaluating at minus 2, we just evaluated at 0 and 2, which becomes easier. That is how integration of the definite integral or evaluation of definite integrals becomes easier by using E-V-naught notion. So, let us see some more problems. We want to evaluate the integral, definite integral again, 0 to pi by 4 tan x plus tan cubed x dx. So, as we have decided, take some time, pause the video here, take some time and then come back to this after you have proceeded for something. Well, how do we go about it? Of course, this can be integrated, but using logarithmic functions, which we have not introduced till now. So, what way we should proceed? Well, we substitute u equal to tan x, that is creating problem. So, let us take u equal to tan x. So, what happens? Du becomes secant square x dx, which is 1 plus tan square x dx. Now, you can see that is helping here. This integrand is really tan x into 1 plus tan square x dx. So, this is your u and this is du, right. You have to find, of course, the limits. When x equal to 0, u is 0 because it is tan x, and when x equal to pi by 4, u equal to tan pi by 4, which is 1. So, the limits are from 0 to 1 of u du, right. That is what integral 0 to 1 u du. Okay. So, that gives u square by 2 evaluated at the limits 0 and 1 and subtracted. So, at 0 it is 0 and that gives 1 by 2. So, that is how it will go, but we will be lucky if it comes in that form. If it does not, then of course, we will not be able to integrate now, something else may be required. Okay. So, let us go to next problem. Evaluate integral minus root 3 to root 3 4x divided by square root of 1 plus x square dx. Now, let us find out, it is a symmetric interval. So, immediately we should think of odd or even. Is it an odd function or even function? So, 4x divided by square root of 1 plus x square. If you substitute minus x in place of x, you would get minus 4x divided by square root of 1 plus minus x square, which is again x square, right. So, f of minus x equal to minus f of x. It is an odd function, hence the integral is 0. We do not have to really evaluate it, just odd function, even function criterion give the answer. Okay. So, let us take the next problem. We want to evaluate integral 0 to 1 10 root x divided by 1 plus x to the power 3 by 2 square. So, problem is this x to the power 3 by 2 is here and the root x is there, but we know derivative of x to the power 3 by 2 is 3 by 2 into root x, right. Derivative of x to the power 3 by 2 is equal to 3 by 2 into x to the power half, right. So, you can think of this dx as the differential of x cubed, x to the power 3 by 2. Even differential of 1 is there. So, you can take 1 plus, right, 1 plus x to the power 3 by 2. That is how we are going to substitute and get the result. So, we substitute u equal to 1 plus x to the power 3 by 2, then du becomes 3 by 2 root x, and then we go for the limits. When x equal to 0, substitute x equal to 0, u becomes 1, and when x equal to 1, again substituting, we get u equal to 2. Therefore, the integral can be written as 0 to 1 10 root x by 1 plus x to the power 3 by 2 into 3 by 2 square equal to 10, that constant is there, and then 3 by 2 root x. So, since 3 by 2 root x is du, du equal to this times dx. So, in place of dx, we can substitute 2 by 3 du, right. So, that is what is 2 by 3 du, that corresponds to dx times, so root x times dx becomes 2 by 3 du now, and 1 plus x to the power 3 by 2 square becomes u square, and the limits 0 to 1 becomes 1 to 2. Okay. So, now this is really 20 by 3, and then u square 1 by u square, the u to the power minus 2. So, that is integral is u to the power minus 1 divided by minus 1. So, 1 minus sign comes, you get minus 20 by 3 u to the power minus 1, and to be evaluated at 1 and 2 and subtracted. So, that gives minus 20 by 3 into half, u equal to 2, and minus 1 when u equal to 1. So, that simplifies to 10 by 3. So, it is the observation first that something appears here whose derivative is multiplied there. That is the main thing we have to see and take that as the new variable. That is what the rule of substitution allows us to do. But observation and all these things are yours. Rule of substitution does not say which one to substitute. You have to get it from the problem. Okay, let us take the next problem. We want to evaluate the integral phi to 3 pi by 2 cosine 7 theta by 6 sine minus 5 theta by 6 d theta. Well, there should be difference of 2. We take cosine cubed theta by 6 sine minus 5 theta by 6 d theta. So, here what happens with this, I change to cube because it will be easier to see with tan. This sine minus 5 and cosine cubed, we can write as sine minus 5 cosine 5 into secant square. So, that gives sine by cos to the power minus 5 and secant square. So, derivative of this sine by cos, which is tan, is really secant square. So, we can think of tan of theta by 6 as u. That is what, that will be easier for this problem. Okay. So, let us substitute u equal to tan theta by 6. Then what happens? Du equal to derivative of tan, which gives secant square theta by 6 into theta by 6 with respect to theta gives 1 by 6. And what about the other function? It is cosine 7 theta by 6 times sine of minus 5 theta by 6, that we can write tan minus 5, this is not 7, this is 3. So, it becomes tan minus 5 theta by 6 into secant square theta by 6. So, it is really cosine minus 2, right, here cosine 5. So, that gives you cosine 3. Then we get tan minus 5 theta by 6 secant square theta by 6 d theta equal to 6 u to the power 5 du, right, u to the power minus 5 du, because du equal to 1 by 6 secant square theta by 6. So, 1 6 times du comes 6 u to the power minus 5 comes here, because tan, right, that gives u to the power minus 5. So, that is how the integrand now looks like. It will integrand of 6 u to the power minus 5 du, and we have to take the limits, of course. So, when theta equal to pi, u equal to tan of theta by 6 pi by 6, it is 1 by root 3, and when theta is 3 pi by 2, u is 1 by 6 times 3 pi by 2, right, which is pi by 4, that gives you tan of pi by 4 is 1. So, we can write the integral pi to 3 pi by 2 cosine of 3 cosine cubed really theta by 6 sine minus 5 theta by 6 as 1 by root 3 to 1 6 u to the power minus 5, right, du. So, when you integrate, it is u to the power minus 5, that gives u to the power minus 4 divided by minus 4 and evaluated at 1 by root 3 to 1, right. So, that after evaluation gives to 12. So, there is a change, you take care of that. That is how it looks, fine. Okay. So, let us go to next problem. Find the indefinite integral, now it is not definite, indefinite integral t to the power minus 2 sin square 1 plus 1 by t dt. So, here what happens, we have t to the power minus 2 dt, we have 1 by t here, and we know the derivative of 1 by t, okay, t to the power minus 1 is minus t to the power minus 2, and if you add 1 of course the same derivative you would get. So, it suggests that we should substitute a new variable for 1 plus 1 by t. That is what we do. Let us write u equal to 1 plus 1 by t. Then du is minus t to the power minus 2 dt. So, that accounts for this differential, and sin square 1 plus 1 by t becomes sin square u, but sin square we do not have formula directly to integrate. So, we rewrite it as half into 1 minus cosine 2 u. Then the indefinite integral becomes minus comes from here, minus sin square u and du. So, that is half of cosine 2 u minus 1 du. Now, cosine 2 u du, so that gives you sin 2 u by 2 and 1 half is here. So, it is sin 2 u by 4 and minus 1 gives minus u, half is there, plus C1, that is the indefinite integral. So, just simplify, because we have to simplify after putting in the substitution, it is in u now, it has to be transferred to t. So, you substitute back, it is sin of 2 plus 2 by t divided by 4 minus u is 1 plus 1 by t. So, by substituting 1 plus 1 by t divided by 2, this gives half and this gives 1 by t. So, minus half is extra, it is minus sign is there already, minus u by 2. So, this is minus half minus 1 by 2 t plus C1. Now, C1 is an arbitrary constant. So, C1 minus half can be written as a new constant C. That is how the indefinite integral will look like now for any arbitrary constant C. So, see how we accommodated some particular constant with the arbitrary constant. So, that indefinite integral there is no need to keep this minus half. Also, you could have kept this minus half plus C1, that is also correct. Fine. Let us go to next problem. If f prime of x equal to sin x by x, then we want to express the integral 1 to 3 sin 2x by x dx in terms of f. So, it is a complicated one. It says that we want to evaluate this integral or express this integral 1 to 3 sin 2x by x in terms of a function whose derivative is sin x by x. We do not know exactly whose derivative sin x by x is, right. So, it looks rule of substitution should help. Now, you want to express it in terms of f whose derivative is sin x by x. So, we should have sin x by x here first, then we can think what to do, right. So, let us take first sin 2x. So, let us take u equal to 2x. With that we have du equal to 2 dx, when x equal to 1 u equal to 2 and when x equal to 3 u equal to 6. It is just twice of that. So, 1 to 3 integral sin 2x by x dx, this one can be written as 1 to 3 2 times sin 2x by 2x dx, which is integral 2 to 6 sin u by u du. Fine. Now, sin u by u is given to be f prime x, that is why we have done it. So, this is really f prime of u. So, this is equal to integral 2 to 6 f prime of u du, and by fundamental theorem of calculus it is just its integral will be f of x. So, f of x from 2 to 6, and that is equal to f of 6 minus f of 2. Now, we are able to express it in terms of f, and in the abstract of course, the indefinite integral will be f of x plus some constant, right. So, when you differentiate it, you would get back. Okay. So, let us stop here.